Hello and welcome to our second part for DMA 20, Section 5, where we'll continue our discussion on multiplying and dividing mixed numbers. Remember last time we introduced the concept of mixed numbers. We learned how to convert mixed numbers to improper fractions and then vice versa, improper fractions to mixed numbers. In this video, we'll learn how to graph mixed numbers on a number line. Then we'll learn the rules for multiplying and dividing mixed numbers, and then finally an application problem. First, we'll learn how to graph mixed numbers on the number line. Here we're going to graph three mixed numbers, negative 1 and 1/4, 2 1/2, and 9/4, which is actually an improper fraction. So let's start with the first one, negative 1 and 1/4. We know that since it's a negative number, we're going to have to go to the left of 0. So we're going to start from 0 and move to the left since it's negative. Now the whole of this number, the negative 1, counts how many whole spaces that will go. So we'll go negative 1 spaces to negative 1. And then there's an additional 1/4 left over. So we're going to continue to the negative direction for 1/4. To do that, we'll have to break up this hole between 1 and 2 into 4 different sections. So I'll do that now. There's the half, and then these will be roughly the quarters. So 1/4 away from the negative 1 would be here, 1/4 after that. So that's where negative 1 and 1/4 will be placed. Next we have 2 1/2. So that means our hole 2 will go 2 holes after, and then 1 to the right in the positive direction, and after that we'll continue in the positive direction for an extra half. So the denominator of the half is 2. I'll break this into 2 roughly equal pieces. And 1/2 beyond 2 is just going to be at that line I just drew. So right there we'll have 2 1/2. Lastly, we have 9/4. Now we could break all of our positive holes into fourths until we get 9, but I think it'll be a little quicker if we just convert 9/4 into a mixed number first. 9 divided by 4 is 2. 2 times 4 is 8, so there's one more fourth left over to get 9/4. And if we checked our math, 2 times 4 is 8, plus 1 is 9. That's great, 9/4. That means we have 2 holes and then 1/4 left over. So I'm going to go ahead and continue breaking this hole up into fourths. So again, 1/4 beyond that 2 is going to be this first fourth right here. So this is where my 9/4 would be placed. Now we have all of those numbers graphed. Now we finally get to the main goal of this section, which is the rules for multiplying and dividing mixed numbers. To multiply or divide a mixed number, first change the mixed number to an improper fraction. Then perform the multiplication or the division of the fractions in the rules that we learned in the previous sections. Write the result as a mixed number or a whole number in simplest forms. So best practices say if you are given mixed numbers in a problem, you should always end with a mixed number, because that's the kind of realm that we're dealing with. So that's always why it's important to write the result as a mixed number or a whole number if possible. Because if we start with mixed numbers, odds are we're going to want our answer expressed in mixed numbers as well, not in proper fractions. Let's start with some multiplication examples. The first example I have here is 3 1/3 times 2 1/3. So we'll start by writing out what those equivalent improper fractions are, because we're always going to have to convert to improper fractions first. So let's start with the first one. 3 3/3. 3 times 3 is 9, plus 1 is 10, so that's my numerator, over my original denominator of 3, times 2 1/3. 3 times 2 is 6, plus 1 is 7, so that's my numerator, denominator of 3. And now it's time to multiply. I could cancel out common factors here, but I don't see any. The only numbers that these 3's could cancel out would be a 3 on the top, and 7 and 10 aren't divisible by 3, so there aren't any common factors here. Oops. So I can just go ahead and multiply. I multiply across the top. 10 times 7 is 70. Then multiply across the bottom. 3 times 3 is 9. And now I'll have to convert to a mixed number. 70 divided by 9 is 7. Okay, 7. 7 times 9 is 63, so I need 7 more. My remainder there would be 7 over the original denominator of 9. And you may have to do long division to do that. I just didn't have room here. That would look like 70 divided by 9, 7, I guess I do have room, is 63. We subtract, we get 7. So that's our whole, and that's our numerator, and we keep the same denominator. Next we have 9 3/5 times 3 3/4. So we'll start converting there. First fraction. 5 times 9 is 45, plus 3 is 48 over the original denominator, times the second fraction. 4 times 3 is 12, plus 3 is 15 over the original denominator. And in this instance, I do have common factors between the top and the bottom. I am going to cancel those out here, because otherwise 48 times 15, I'm going to get a huge number that I'm going to have to divide by to convert back to later. So it's best to get rid of any common factors now. I see 5s in common between 5 and 15, so I'll divide each of those by 5. I'll get 1 and 3. And 48 and 4 are divisible by 2, because they're both even, but I also notice that they're divisible by 4, so I'm going to divide by the bigger one. 4 divided by 4 is 1, and 48 divided by 4 is 12. Alright, I'm going to rewrite this a little cleaner. Now I have 12 over 1 times 3 over 1 after I cancel out those common factors. I multiply across the top. 12 times 3 is 36, and then the bottom, 1 times 1 is 1, and then 36 divided by 1 is just going to give us the whole number 36. So that's our answer for the second problem. Next we have negative 5/6 times the whole number 2. Remember, this is implied to be a multiplication problem here. Okay, so let's convert. That first one, we're going to keep the sign, so we know this is still going to be a negative fraction. Okay, 6 times 4 is 24, plus 5 is 29. Over the original denominator of 6 times 2. I'm going to express as the fraction 2 over 1. We can write any whole number as over 1. So I'll do that so we have two fractions here. We'll cancel out common factors. 6 and 2 are both divisible by 2. So I'll do that. That divided by 2 will give me 1. That divided by 2 will give me 3. And now I can multiply. Alright, negative 29 times 1 is negative 29, over 3 times 1 is 3. Okay, and now I'm going to convert this to an improper fraction. I'm going to write that negative sign in there so I don't forget my answer is negative. Then I'll just do the regular 29 divided by 3. 9 won't go into 3, but it'll go into 29 9 times. 9 times 3 is 27, and I subtract to get a remainder of 2. That means my whole is going to be the number on top here. That's how many wholes I had. That was 9 over the remainder of 2 over my divisor, or my original denominator of 3. So the answer to this multiplication problem was negative 9 2/3. Now some division examples. We'll start the same by converting everything to improper fractions. Remember, we keep the signs as they come across, so this first one will be a negative. And then we'll start converting. 8 times 3 is 24, plus 3 is 27, over 8, divided by, we're going to have another negative fraction. 4 times 2 is 8, plus 1 is 9, so we get negative 9/4. And now remember our rules for division of fractions. Copy, change, flip, or keep, change, flip. We keep the first one, so we have negative 27 over 8. We change from division to multiplication, and then we flip the second one, so this will be negative 4 over 9. Multiply by the reciprocal. Cancel out any common factors if possible. There's negative 4 and 8 both have 2 in common, or both have 4 in common, so I'll divide them both by 4. I'll get negative 1, and then here I'll get 2. And negative 27 and 9 both have 9 in common. I'll divide this by 9 and get 1. Divide this by 9 and get negative 3. So when I multiply, negative 3 times negative 1 will give me a positive 3. And then 2 times 1 will give me 2. And that sign does make sense. If we look back to the beginning of our problem, we have a negative divided by a negative. We should get a positive answer. So it's good to double check that at the end. Okay? And since we started with an improper fraction, or with mixed numbers, we should end with mixed numbers, so we'll convert this. 2 goes into 3 one time with 1 left over, so we get 2 and 1/2. Next, 1 and 11/16 divided by 3/4. We'll go ahead and convert that first one. 16 times 1 is 16, plus 11 is 27, so we get 27 over 16, divided by 3/4. Now we'll change flip, keep the first one. Change from division to multiplication, and then we'll flip the second one, so it's times 4/3 now. Let's cancel out any common factors. 4 and 16 are both divisible by 4. So I'll divide them both by 4, 4 divided by 4 is 1. 16 divided by 4 is 4. And 27 and 3 are both divisible by 3. 3 divided by 3 is 1. And then 27 divided by 3 is 9. Okay. Multiply across the top, I'll get 9. Multiply across the bottom, I'll get 4. So I get 9/4, which is improper. We should convert this back to a mixed number. 4 goes into 9 twice. That's 8. So there's 1 left over to make it 9 over the original denominator of 4. So the answer to this division problem is 2 and 1/4. Lastly, negative 3 and 4/15 divided by negative 2 and 1/10. We'll have to convert both of those. It starts as negative, so the first fraction will also be negative. 3 times 15 is 45, plus 4 is 49, over the original denominator of 15, divided by another negative fraction. 2 times 10 is 20, plus 1 is 21, so that's 21 over 10, negative 21 over 10. And now, remember the division rules, we'll copy, change, and flip. So, we keep the first, change to multiplication, and then flip the second. And now we'll look for common factors. 49 and 21 are both divisible by 7, so we'll have 7 here, or 3 here. We divide 21 by 7, we get 3. Negative 49 divided by 7 is negative 7. And 15 and negative 10 are both divisible by 5. Divide this by 5 and get 3. Divide negative 10 by 5 and get negative 2. And now I can multiply. Negative 7 times negative 2 will give me a positive 14 over 3 times 3 is 9. Does my signs make sense? Yes, I had a negative divided by a negative in the beginning, so I should have a positive at the end. Last step is going to be to convert to a mixed number. 9 will go into 14 one times. That's 9, so we'll need 5 more to get to 14 over the original denominator of 9. Now finally an application problem. Part of the fire escape stairway, so we're dealing with stairs, for one story of an office building is shown below. Well, no, it's not, but I'll draw it for you. So we've got some stairs, and they kind of keep going up to the top of this building here, okay? And the height of the riser, which is this part, is 7.5 inches. And the height of the entire story, if we went all the way up to the top, is 105 inches. So for part A, we need to know how many stairs there are in one story of the fire escape. Okay, well, if the total is 105 inches and the size of the part is 7.5 inches, we can divide the total by the size of the part to get the number of parts. So that's exactly what we do. The total height is 105 divided by the size of the part, or 7.5. Now, we should rewrite those as improper fractions. Rewrite 105 as 105 over 1 divided by 7 times 2 is 14 plus 1 is 15 over 2. Now we'll need to copy, change, flip, so we'll have 105 over 1 divided by, times 2 over 15. Now cancel out common factors if possible. I think 15 will go into 105 evenly. I think that's 15 times 7. I'm going to check that over here because I'm not too confident about my 15's times tables. So 15 times 7 is 35. And then 7 times 1 is 7, plus 3 is 10. So yeah, 15 will go into both 15 and 105 evenly. So I'm going to divide them both by 15. 15 divided by 15 is 1. And then 105 divided by 15 we just found was 7. So now we can multiply across the top. 7 times 2 is 14. And then on the bottom, 1 times 1 is 1. So we get the whole number 14. And this makes sense, right? We shouldn't have half a stair or a third of a stair or a 15th of a stair in a story. It should be a whole number. So that's great. Next, in part B, if the building has 43 stories, how many stairs are there in the entire fire escape? Well, to figure that out, we just take the number of stories and multiply it by the number of stairs in one story to get the total. So we'll do 43 times 14. And then we'll multiply. 4 times 3 is 12. That's 2 regroup the 1. 4 times 4 is 16, plus 1 is 17. As we move to the next line, we'll add a 0. 1 times 3 is 3. 1 times 4 is 4. Then we'll add these together. 2 plus 0 is 2. 7 plus 3 is 10. That's 0, carry the 1. And then 4 plus 1 is 5, plus another is 6. So there's 602 stairs in this entire building. So that covers the rest of our material in section 5. In this video, we finished up by learning how to graph numbers on a number line, multiply and divide mixed numbers, and then we looked at an application problem. Next up is section 2.6, where we'll learn how to add and subtract mixed numbers.